In the sterile white light of a surgical theatre in Montreal, 1953, something extraordinary was about to happen. Wilder Penfield adjusted his electrical probe, its metal tip hovering millimeters above exposed brain tissue. The patient lay conscious on the operating table, her skull opened like a window into the most mysterious territory in the known universe. What happened next would launch humanity's most daring expedition, the quest to understand consciousness itself. The probe touched down on temporal lobe tissue, sending a tiny electrical current through neurons that had been firing silently in darkness for 43 years. Suddenly, the patient's eyes widened. She was no longer in the surgical theatre. She was 8 years old again, standing in her childhood kitchen on a bright Sunday morning. She could taste chocolate cake on her tongue, smell her mother's lavender perfume, feel sunlight streaming through curtains that had been thrown away decades ago. The memory wasn't just recalled, it was relived with every sensory detail intact. Penfield had discovered something that shouldn't exist according to everything science understood about the brain. A few volts of electricity applied to specific tissue could unlock entire worlds of experience, complete with emotions, sensations, and memories so vivid they felt more real than the present moment. He was touching consciousness directly, mapping the territories where subjective experience lives. Here's what was really happening in that Montreal operating room. The human brain contains 86 billion neurons, ABPS, more than 3 times the number of stars in our galaxy. These neurons form connections called synapses, and each neuron can connect to thousands of others, creating a network so complex that the total number of possible states exceeds the number of atoms in the observable universe. When Penfield's probe delivered its electrical signal, it was artificially activating specific pathways within this vast network, triggering cascades of neural activity that normally occur only when we experience events in real time. But the deeper mystery wasn't just that memories could be triggered electrically. The profound question was why those electrical patterns create any subjective experience at all. Why should arrangements of matter give rise to the feeling of being someone experiencing something? This is the central puzzle that consciousness science still grapples with today. How does the wetware of biology generate the software of awareness? The journey to understand consciousness began long before Penfield's electrical explorations. 3,500 years ago, Egyptian physicians were documenting something they called specifications for wounds of the head. They had noticed that injuries to specific parts of the skull caused predictable changes in personality and behavior. A blow to the left temple might rob someone of speech. Damage to the back of the head could steal vision while leaving all other faculties intact. These ancient healers were making the first tentative maps of consciousness, connecting the physical brain to the mysterious realm of mind. But it was René Descartes in the 1600s who articulated the deepest challenge consciousness poses to human understanding. Sitting by his fireplace in doubt of everything he could possibly doubt, Descartes realized there was one thing that remained absolutely certain, the very fact that he was experiencing doubt. "I think, therefore I am," he declared, establishing consciousness as the one indubitable fact about reality. You can doubt the existence of the external world, question whether your memories are real, and wonder if you're dreaming, but you cannot doubt that you are having an experience of doubt. Consciousness is the foundation upon which all knowledge rests. This realization created what philosophers call the hard problem of consciousness. We can explain the brain's functions, how it processes information, controls movement, stores, and memories. These are complex but ultimately mechanical processes. The hard problem is explaining why there's something it's like to have these processes occurring. Why do we have inner experience at all? Why isn't the brain just a sophisticated computer, processing inputs and generating outputs in darkness, with no one home to witness the process? The stakes of this question became horrifyingly clear in the development of surgery. Until 1846, Every surgical operation in human history was performed on fully conscious patients. Before William Morton's demonstration of ether anesthesia at Massachusetts General Hospital, surgery meant enduring unimaginable pain while remaining completely aware of every cut, every probe, every manipulation of living tissue. Patients were held down by strong men, while surgeons worked as quickly as possible, racing against shock and blood loss. The agony was so extreme that many chose death over the surgeon's knife. The discovery of anesthesia revealed something profound about consciousness. It could be chemically altered, dampened, or eliminated entirely while leaving the body's other functions intact. This wasn't just sleep, where consciousness dims but doesn't disappear. Under anesthesia, the lights of awareness went out completely. Patients could be cut open, their organs manipulated, bones sawed, and they experienced nothing at all. No memory formed, no sensation registered. It was as if consciousness had been temporarily deleted from reality. This discovery raised new questions. If consciousness could be switched off chemically, what exactly was being switched off? General anesthetics work by disrupting communication between different regions of the brain, preventing the integrated activity that seems necessary for awareness. But why should integration create subjective experience? A computer can integrate information without feeling anything. What makes biological integration special? The answers began emerging as neuroscience developed more sophisticated tools for studying the living brain. Scientists discovered that consciousness isn't located in any single brain region but emerges from the dynamic interaction between many areas working together. Damage specific regions and you lose specific aspects of consciousness. Destroy the visual cortex and the world goes dark. Lesion Broca's area and speech vanishes while thoughts remain intact. Damage the angular gyrus and you might experience yourself floating outside your body, watching from above. But perhaps the most revealing discoveries came from studying what happens when the brain's two hemispheres are surgically separated. In the 1960s, Roger Sperry and his colleagues began cutting the corpus callosum, the bundle of 200 million nerve fibers connecting the brain's left and right hemispheres, to treat severe epilepsy. These split-brain surgeries were medically successful, but they revealed something extraordinary about the nature of consciousness. Patients with severed corpus callosums seemed normal in everyday life, but careful testing revealed they had effectively become two separate conscious minds sharing one body. Each hemisphere processed information independently and could make decisions without the other's knowledge. In laboratory tests, information presented to only the right hemisphere, TENI5, which controls the left hand but cannot speak, would trigger actions the left hemisphere, which controls speech, couldn't explain. Patients would find their left hand unbuttoning their shirt while their right hand tried to button it up again, or reaching for objects they couldn't verbally identify. These studies demonstrated that consciousness isn't a single unified phenomenon, but something that can be divided. What we experience as the seamless unity of awareness is actually the result of constant communication between different brain systems. When that communication is severed, multiple consciousnesses can coexist in the same skull, each unaware of the other's existence. The split-brain studies also revealed the brain's remarkable capacity for creating explanations. When the right hemisphere was shown an image and directed the left hand to perform an action, the verbal left hemisphere would confidently fabricate a reason for the behavior it couldn't understand. This discovery suggested that much of what we think of as rational consciousness might actually be our brain's storytelling system, working overtime to create coherent narratives from fragmented information. As brain imaging technology advanced, scientists could watch consciousness in action for the first time. Positron emission tomography and functional magnetic resonance imaging allowed researchers to see which brain regions were active during different conscious experiences. They discovered that consciousness emerges from the coordinated activity of networks spanning the entire brain. When you see a red rose, visual areas process color and shape, memory systems retrieve associations with roses, emotional centers generate feelings of beauty or nostalgia, and language areas prepare words to describe the experience. All of this happens in milliseconds, creating the unified experience of seeing a rose. But the most profound revelation was that consciousness is far more fragile than we imagine. The brain processes 11 million bits of information every second, but our conscious awareness accesses only about 50 bits. The vast majority of mental processing happens below the threshold of awareness, in unconscious systems that control everything, from heartbeat to the movements of your eyes as you read these words. Consciousness is just the tip of an enormous iceberg of mental activity. This realization forced scientists to reconsider what consciousness actually does. If 99.5% of brain processing happens unconsciously, why does consciousness exist at all? What advantage does subjective experience provide that unconscious processing cannot? Some researchers propose that consciousness serves as a kind of global workspace where different brain systems can share information and coordinate their activities. Others suggest it's an emergent property of sufficiently complex information processing, arising naturally when neural networks reach a certain threshold of integration and complexity. The search for consciousness has taken researchers into increasingly exotic territories. They've studied patients with blind sight who can navigate obstacles they swear they cannot see, their unconscious visual systems guiding behavior while conscious vision remains dark. They've examined people with split personalities who appear to have multiple streams of consciousness, alternating control of the same body. They've investigated the altered states produced by psychedelic drugs, where the normal boundaries of self and world dissolve into oceanic unity. Each discovery has deepened the mystery while revealing new aspects of consciousness's complexity. We've learned that awareness can be present without memory, that memories can feel utterly real while being completely false, that the sense of self can be temporarily dissolved while leaving other aspects of consciousness intact. We've discovered that consciousness isn't binary, either on or off, but exists in degrees and varieties we're only beginning to catalogue. Today, as we develop brain-computer interfaces that can read thoughts directly from neural activity and artificial intelligence systems that display behaviors once thought to require consciousness, the questions Penfield first probed with his electrical stimulator have become more urgent than ever. If consciousness can be measured, manipulated, and potentially replicated, what does it mean to be conscious? What makes your inner experience uniquely yours? The story of consciousness science is ultimately the story of the universe, becoming aware of itself. Through billions of years of evolution, matter organized itself into forms capable of experiencing their own existence. In studying consciousness, we're not just investigating a biological phenomenon, some die. We're exploring the deepest mystery of existence itself. Why is there something it's like to be anything at all? From that Montreal operating theatre in 1953 to the cutting-edge laboratories of today, we've been mapping the territories where mind meets matter, where subjective experience emerges from objective reality. We've discovered that consciousness is both more fragile and more resilient than we ever imagined, both more mysterious and more measurable than previous generations could have conceived. The journey to understand consciousness has revealed that we are walking mysteries, has organized itself into forms capable of wondering about their own existence. Every moment of awareness represents the culmination of 13.8 billion years of cosmic evolution. From the first stirrings of complexity and primordial matter to minds capable of contemplating infinity itself. As we stand on the threshold of potentially creating artificial consciousness and enhancing human awareness beyond its current limitations, we carry with us the profound responsibility of beings who have become conscious of consciousness itself. We are the universe's way of understanding itself, star stuff that has learned to wonder about stars. Every morning, as you emerge from sleep, something miraculous happens that you never notice. Consciousness doesn't simply switch on like a light bulb. It builds itself from the ground up in precisely orchestrated waves, constructing the feeling of being you from neural foundations laid down over millions of years of evolution. Deep within your brain, 86 billion neurons fire in patterns more complex than all the stars in our galaxy, creating something that shouldn't exist according to everything. Physics tells us about matter, the undeniable sensation of being alive and aware. The architecture of consciousness begins in the basement of your brain, in the brainstem, a structure so ancient and essential that damage here means the lights of awareness go out forever. This thumb-sized region at the top of your spinal cord contains the circuits that have kept vertebrates conscious for 500 million years. Here, in clusters of neurons with names like the locus coeruleus and the raphe nuclei, consciousness maintains its most fundamental foundation. Think of the brainstem as consciousness's power plant. Every second of every day, specialized neurons here release chemical signals that determine whether you're awake, asleep, or somewhere in between. Norepinephrine from the locus coeruleus keeps your mind alert and focused. Serotonin from the raphe nuclei modulates mood and maintains the delicate balance between waking and sleeping. When these systems malfunction, consciousness fragments in predictable ways. NDAs, depression, clouds awareness, anxiety fractures attention, and damage to specific nuclei can leave patients locked in perpetual sleep. But consciousness needs more than just arousal. It requires integration. One floor up from the brainstem sits a structure the size of a walnut that operates as consciousness's grand central station, the thalamus. This olive-shaped mass of grey matter routes 40 million signals per second between different brain regions, determining what information reaches consciousness and what remains hidden in unconscious processing. Here's what's actually happening inside your thalamus right now. As you read these words, visual signals from your eyes arrive at the lateral geniculate nucleus, where they're filtered, amplified, and routed to visual cortex. Simultaneously, the ventral posterior nucleus processes touch sensations from your fingers holding this device, while the medial geniculate nucleus handles any sounds in your environment. All of this information converges in thalamic nuclei that act like switchboard operators, deciding which signals deserve consciousness's limited bandwidth. The moment this olive-sized structure shuts down, consciousness vanishes like a blown fuse. Patients with thalamic strokes often fall into comas not because their cortex is damaged, but because the central relay station that binds disparate brain regions into unified experience has gone offline. When neurosurgeons stimulate the thalamus during brain surgery, patients describe their consciousness flickering like a faulty fluorescent light. TESS, awareness dimming and brightening, as electrical current modulates the flow of information through consciousness's central hub. From the thalamus, the construction of consciousness spreads outward through the cortex in waves that neuroscientists can now track with millisecond precision. The cortex, a brain's wrinkled outer layer containing 16 billion neurons, is where the rich textures of conscious experience emerge. But the cortex isn't a single structure, any more than a city is a single building. It's a vast metropolis of specialized neighborhoods, each contributing different elements to the symphony of awareness. In the primary visual cortex at the back of your brain, millions of neurons extract edges, colors, and movements from the chaos of photons hitting your retinas. These simple features get passed forward to association areas that recognize objects, faces, and scenes. Meanwhile, auditory cortex transforms pressure waves into melodies, voices, and meaningful sounds. Somatosensory cortex maps every square inch of your body's surface, creating the felt sense of having a physical form. All of these specialized processes work simultaneously, their outputs binding together into the unified movie of consciousness you experience every waking moment. But perhaps the most The extraordinary aspect of consciousness's architecture is how it manages to feel unified despite being constructed from millions of separate processes. When you see a red rose, visual areas process its color and shape. Memory systems retrieve associations and names. Emotional centers generate feelings of beauty or memory, and motor areas prepare your hand to reach for it. Yet you don't experience these as separate streams of processing, and they bind together into a single coherent perception of seeing a rose. This binding happens through synchronization, AZ, neurons in different brain regions firing in precise rhythm with each other, like musicians in an orchestra following the same conductor. When visual areas processing the rose's red color fire in sync with areas processing its shape, and with memory systems retrieving the concept rose, these separate streams of information merge into unified conscious experience. Break this synchronization, too few, through drugs, brain damage, or targeted magnetic stimulation, MAI, and consciousness fractures into disconnected fragments. The left and right hemispheres of your brain represent consciousness's most dramatic architectural division. Connected by the corpus callosum, a bridge of 200 million nerve fibers, these hemispheres normally work in seamless cooperation. But as Roger Sperry's split brain studies revealed in the 1960s, severing this connection creates something extraordinary. Two separate streams of consciousness sharing one skull. In split brain patients, each hemisphere develops its own preferences, memories, and decision-making processes. The left hemisphere, which controls language, can describe its experiences and intentions, but the right hemisphere, though unable to speak, demonstrates its own form of consciousness through actions. Show a split-brain patient a picture to only their right hemisphere, and their left hand will draw what they saw while their verbal left hemisphere honestly claims to have seen nothing. These studies revealed that what we experience as the unity of consciousness is actually an achievement, the result of constant communication between brain hemispheres that normally share every experience. When neuroscientist Michael Gazzaniga tested split-brain patients, he discovered that the verbal left hemisphere acts like a relentless narrator, constantly creating explanations for behaviors it doesn't understand. If the right hemisphere directed the left hand to stand up, the left hemisphere would confidently explain, "I wanted to stretch," having no awareness that another consciousness in the same skull had initiated the action. But consciousness isn't just about processing and integrating information. It's about experiencing it subjectively. And here's where the architecture becomes truly mysterious. Scientists can map every pathway, measure every firing pattern, and trace every connection, but they still can't explain why any of this should feel like anything at all. Why should synchronized neural firing create the redness of red or the pain of a pinprick? This is what philosopher David Chalmers calls the hard problem, explaining why there's something it's like to have brain states at all. The answer may lie in consciousness's most remarkable architectural feature, its recursive nature. Your brain doesn't just process information, it processes information about its own information processing. You're not just aware of the red rose, you're aware that you're aware of it. This self-referential loop, where the brain monitors its own states, may be the key to understanding how subjective experience emerges from objective neural activity. Recent research has identified specific brain networks that seem essential for this self-awareness. The default mode network, active when you're not focused on external tasks, maintains your sense of self and personal narrative. The salience network determines what deserves your attention moment by moment. The central executive network controls focused attention and working memory. These networks interact in complex patterns that correlate with different states of consciousness, from normal waking awareness to the altered states produced by meditation, anesthesia, or psychedelic drugs. Perhaps most remarkably, consciousness appears to have hot zones, brain regions, specific brain regions, where damage reliably eliminates categories of conscious experience. The posterior hot zone, a region of cortex no thicker than a few sheets of paper, seems particularly crucial. Damage here can erase visual consciousness while leaving patients able to navigate obstacles they swear they cannot see. Stimulation of this region during brain surgery can trigger profound experiences, cosmic feelings of unity, encounters with deceased relatives, or the sensation of leaving one's body entirely. These hot zones suggest that consciousness isn't equally distributed throughout the brain. Some regions contribute more to subjective experience than others, and some may be absolutely essential. When neuroscientist Christoph Koch maps these critical areas, he finds they're characterized by exceptionally rich connectivity. Neurons here form dense webs of connections, both locally and with distant brain regions. It's as if consciousness emerges from the most highly networked neighborhoods of neural activity. But consciousness's architecture extends beyond individual brain regions to encompass the entire nervous system. Your consciousness includes not just thoughts and perceptions, but the felt sense of having a body. This embodied awareness depends on constant streams of information from throughout your body: the stretch of muscles, the position of joints, the fullness of your stomach, the rhythm of your heartbeat. All of this bodily information gets integrated into the sense of being a conscious self inhabiting a physical form. The gut alone contains 500 million neurons, more than the brain of many vertebrates. This second brain communicates constantly with the brain in your skull through the vagus nerve, influencing mood, decision-making, and even personality. When you have a gut feeling about something, you're literally experiencing the neural wisdom of your abdominal brain contributing to consciousness. Even more remarkably, consciousness seems to extend beyond the boundaries of individual brains in certain circumstances. When people synchronize their breathing during meditation or fall into deep conversation, their brain waves begin to align. Musicians playing together show remarkable neural synchronization, their consciousness temporarily merging into something larger than the sum of its parts. This suggests that consciousness's architecture may be more flexible and expansive than we typically imagine. The construction of consciousness each morning follows a predictable sequence that researchers can now track in real time. As you emerge from sleep, brainstem arousal systems gradually increase their activity. The thalamus begins routing signals more efficiently between brain regions. Cortical networks slowly synchronize their firing patterns. Information integration increases moment by moment until the threshold is crossed and you suddenly find yourself awake and aware. But consciousness doesn't just turn on, it tunes itself. The brain maintains its own conscious state through continuous feedback loops that monitor and adjust the level of awareness. Too little arousal and consciousness dims towards sleep. Too much, and it fragments into anxiety or overstimulation. The healthy brain constantly calibrates itself to maintain optimal conscious functioning, like a musician tuning an instrument throughout a performance. This self-regulating quality explains why consciousness feels so stable, despite being constructed from the chaotic activity of billions of individual neurons. Your sense of being a continuous self persists, even though the physical matter of your brain completely replaces itself every few years. The neurons firing right now are not the same ones that were firing when you woke up this morning, yet your consciousness feels seamlessly continuous. Understanding consciousness's architecture has profound implications for how we think about mental health, artificial intelligence, and the nature of human experience itself. Depression may represent a breakdown in the integration between emotional and cognitive brain networks. Schizophrenia might involve excessive connectivity that floods consciousness with irrelevant information. Autism could reflect differences in how sensory information gets integrated into conscious experience. As we develop technologies that can read neural activity in real time and brain-computer interfaces that respond directly to conscious intentions, we're beginning to interact with consciousness's architecture in unprecedented ways. Soon, We may be able to enhance memory formation, boost attention, or even share conscious experiences directly between minds. But perhaps the most profound insight from mapping consciousness's architecture is how contingent and fragile our awareness really is. The feeling of being a unified, continuous self depends on the precise coordination of networks spanning the entire brain. Alter the chemistry slightly with drugs or meditation, damage specific regions through injury or disease, or disrupt the communication between hemispheres, and consciousness transforms in dramatic ways. We are walking architectural marvels, living proof that matter can organize itself into forms capable of experiencing their own existence. Every moment of awareness represents the successful coordination of billions of neural conversations, the binding of disparate information streams into unified experience, and the emergence of something that feels like someone home to witness it all. The architecture of awareness reveals consciousness not as a single thing, but as an ongoing process, a dynamic dance of neural activity that creates the stage upon which all human experience unfolds. We are the universe's most sophisticated experiments in self-awareness, biological structures that have evolved the capacity to understand their own construction. Tomorrow, we'll explore how this magnificent architecture came to exist through evolution's 4-billion-year experiment in building conscious minds. 520 million years ago, in the warm, shallow seas of the Cambrian period, something unprecedented happened that would change the universe forever. For the first time in Earth's 4-billion-year history, something opened its eyes and saw, not human consciousness. That remarkable achievement lay hundreds of millions of years in the future, but something simpler, yet profound beyond measure. The first stirring of subjective experience, the dawn of what it feels like to be something experiencing the world. The moment consciousness began, the universe gained a witness. Before that first primitive eye detected light and shadow, all of Earth's processes, the crashing of waves, the blooming of algae, the drift of continents, occurred in darkness, with no one present to experience them. When that first conscious creature perceived its environment, reality gained an inside, a subjective dimension that hadn't existed before. The cosmos had been performing for 4 billion years to an empty theatre. Finally someone was watching, but consciousness didn't emerge from nothing. It arose from life's relentless experimentation with information processing and response systems. The earliest single-celled organisms already possessed rudimentary abilities to sense and respond to their environment. A bacterium can detect chemical gradients and swim toward nutrients or away from toxins. Even these microscopic creatures exhibit something that looks like preference and choice, though we hesitate to call it consciousness. The unspeaked revolution came when evolution invented multicellular life, and with it, the possibility of specialized cells dedicated to sensing and responding. In ancient jellyfish, some of the oldest complex animals still alive today, we see consciousness's first blueprints. These translucent drifters possess nerve nets, simple networks of interconnected neurons that can detect light, touch, and chemical signals. When a jellyfish encounters food, its nerve net coordinates a feeding response. When threatened, it contracts and pulses away from danger. Here's what's remarkable about jellyfish consciousness. It's distributed throughout their bodies with no central brain to coordinate it. Each part of the nerve net can sense and respond independently, yet somehow the animal maintains unified behavior. This distributed consciousness represents one of evolution's earliest experiments in awareness, a form of mind without a central mind, experience without a unified experiencer. From these humble beginnings, nature began its greatest creative project, building minds. Over hundreds of millions of years, evolution experimented with countless variations on the theme of consciousness. Some lineages concentrated neural control into central brains, others maintained distributed networks. Some emphasized visual processing, others chemical sensation. still others the detection of electrical fields. Each experiment revealed new possibilities for what consciousness could become. In the ancient oceans, arthropods developed compound eyes with thousands of facets, each detecting a tiny slice of the visual world. Their brains learned to integrate these fragments into coherent images, solving the computational challenge of binding separate inputs into unified perception. Trilobites, those ubiquitous Paleozoic creatures, possessed some of the most sophisticated visual systems ever evolved, with crystalline lenses that could focus light with mathematical precision. Through their eyes, consciousness first glimpsed the underwater landscapes of primitive Earth. But perhaps the most extraordinary consciousness experiment occurred in the cephalopod lineage, HIAS, the ancestors of today's octopuses, squids, and cuttlefish. Here, evolution took a radical approach to building minds. Instead of concentrating all neural processing in a central brain, cephalopods distributed intelligence throughout their bodies. An octopus possesses 550 million neurons, arms, comparable to a dog, but 2/3 of them reside not in its brain but in its 8 arms. Each octopus arm contains 35 million neurons organized into clusters that can process information and make decisions independently. An octopus arm can taste what it touches, explore crevices without conscious direction from the central brain, and even continue moving and responding after being severed from the body. Yet somehow, this distributed intelligence maintains unified consciousness and purposeful behavior. Watch an octopus hunt and you witness consciousness operating according to principles utterly alien to our own. The animal's skin becomes a dynamic display of color and texture, not just for camouflage but as a form of visual thinking made manifest. Emotions, intentions, and sensory experiences flow across the octopus's body as shifting patterns of chromatophores, EBCT, specialized skin cells that can change color in milliseconds. The octopus doesn't just think, it thinks visibly, its consciousness literally written across its skin. Meanwhile, in entirely different evolutionary lineages, consciousness was exploring other possibilities. Social insects like bees and ants developed collective forms of awareness that emerge from the interactions of thousands or millions of individuals. A honeybee's brain contains only 900,000 neurons, tiny compared to vertebrate brains. Yet these insects navigate complex three-dimensional landscapes, communicate the location of distant food sources through symbolic dances, and make collective decisions about nest sites that display remarkable wisdom. The bee's consciousness includes sensory experiences we can barely imagine. They see ultraviolet patterns on flowers invisible to us, navigate by polarized light that our eyes cannot detect, and sense the Earth's magnetic field with specialized iron crystals in their abdomens. When a bee returns to the hive with news of a rich flower patch, its waggle dance translates visual memories into motor patterns that other bees decode back into spatial information. Consciousness, in the insect world, became inherently social and communicative. But it was in the vertebrate lineage that consciousness achieved its most familiar and perhaps most sophisticated expressions. Fish, the earliest vertebrates, developed centralized brains that could integrate information from multiple sensory modalities and coordinate complex behaviors. In these ancient swimmers, we see the first glimmerings of what would eventually become human consciousness, unified experience emerging from specialized brain regions working in concert. The transition to land marked another crucial phase in consciousness evolution. Amphibians and early reptiles faced the challenge of processing dramatically different sensory environments as they moved between water and air. Their brains evolved new structures to handle terrestrial vision, airborne sounds, and the novel sensory demands of gravity-based movement. Consciousness was learning to be flexible, to adapt its processing to radically different environments. When warm-blooded mammals emerged, consciousness gained a new dimension, the ability to maintain stable awareness across a wide range of environmental conditions. Mammals developed sophisticated emotional systems and social behaviors that required new forms of conscious experience, the ability to feel attachment, to experience empathy, to maintain emotional bonds across time and distance. Perhaps most remarkably, some mammalian lineages began developing what we now recognize as higher-order consciousness, ACA, awareness not just of the environment, but of their own mental states. Elephants, with their massive brains containing 3 times as many neurons as humans, display behaviors that suggest profound self-awareness. They recognize themselves in mirrors, mourn their dead, and return to stroke the bones of deceased family members years after death. Their consciousness appears to include concepts of mortality and memory that span generations. In the cetacean lineage EHE, whales and dolphins, consciousness took yet another extraordinary turn. These marine mammals possess brains that dwarf our own in absolute size. A sperm whale's brain weighs 17 pounds and contains specialized neurons called spindle cells, found only in the most conscious species. These elongated neurons, which appeared in whale ancestors 15 million years before they evolved in apes, may be crucial for self-awareness and complex emotional processing. Dolphins developed perhaps the most remarkable consciousness of all. Their brains never completely sleep. One hemisphere rests while the other remains vigilant, maintaining awareness every moment from birth to death. They've evolved their own forms of culture, passing learned behaviors through generations, and display mirror self-recognition at earlier ages than human children. Their consciousness operates in a medium of echolocation, where sound becomes sight, where they can literally see inside objects and each other's bodies. The primate lineage, culminating in humans, represents consciousness's most recent major innovation, the ability to think about thinking itself. Our ancestors developed prefrontal cortices, capable of modeling not just the external world but their own mental processes. This metacognitive ability, ISY, consciousness becoming conscious of itself, opened up entirely new realms of experience. Human consciousness includes capabilities that appear unique in the known universe. We can imagine counterfactual scenarios, contemplate abstract concepts, create symbolic representations of our thoughts, and transmit complex ideas across space and time through language. We've developed the ability to enter other minds through story and empathy, to experience vicarious emotions, and to suffer or rejoice over purely imagined situations. But perhaps our most extraordinary achievement is the capacity for recursive self-awareness, ACE, the ability to be conscious of our own consciousness. You can think about your thoughts, experience your experiences, and be aware that you are aware. This creates an infinite hall of mirrors where consciousness can reflect on itself indefinitely. No other known form of consciousness possesses this degree of self-referential depth. The evolutionary history of consciousness reveals several crucial insights about its nature. First, consciousness is not binary, either present or absent, but exists in countless degrees and varieties. Every species with a nervous system possesses some form of subjective experience, from the distributed awareness of jellyfish to the recursive self-consciousness of humans. Second, consciousness is incredibly diverse in its manifestations. Evolution has produced minds that operate according to principles radically different from our own, from the skin-based thinking of octopuses, to the echolocating consciousness of dolphins, to the collective awareness of social insects. This diversity suggests that human consciousness represents just one possible solution to the challenges of awareness. Third, consciousness tends to increase in complexity over evolutionary time. While simple forms of awareness remain successful, APP, bacteria and jellyfish continue to thrive, there's a clear trend toward more sophisticated forms of conscious experience. This suggests that consciousness provides genuine survival advantages, despite the enormous energetic costs of maintaining complex brains. Most profoundly, The evolutionary history of consciousness reveals it to be the universe's most remarkable achievement. Through billions of years of trial and error, matter has organized itself into forms capable of experiencing their own existence. The same atoms that once swirled in stellar furnaces now contemplate stars from behind human eyes. Hydrogen forged in the Big Bang has become neurons, firing thoughts about their own cosmic origins. We are not separate from this evolutionary process, but its current culmination. Every moment of human consciousness represents 4 billion years of ancestral experiences, from the first stirring of awareness in Cambrian seas to the recursive self-reflection of modern minds. We carry within our brains the entire history of consciousness on Earth, ancient reflexes from fish ancestors, emotional systems from early mammals, social instincts from primate forebears. Understanding consciousness evolution also reveals our profound responsibility as the first species capable of understanding its own consciousness. We're not just products of evolution, but potential directors of consciousness's future development. Through technology, we're beginning to enhance and extend awareness beyond its current biological limitations. Through artificial intelligence, we may soon create entirely new forms of conscious experience. The story of consciousness evolution is ultimately the story of the universe awakening to itself. From the first primitive eye-opening in Cambrian seas to human minds contemplating the cosmos, consciousness represents matter's greatest achievement, the creation of experience itself. We are evolution's most sophisticated experiment in self-awareness, the culmination of life's 4 billion-year journey toward understanding its own existence. But our story is far from over. As we stand on the threshold of creating artificial consciousness and enhancing human awareness, we continue evolution's greatest project. The universe is still awakening, still discovering new forms of consciousness, still exploring the infinite possibilities of what it means to experience existence itself. In a sterile hospital room in Liège, Belgium, 2006, a woman who had been silent for 23 years was about to shock the world of neuroscience. Rom Huben had been diagnosed as vegetative since a devastating car accident in 1983. For more than 2 decades, he lay motionless in his hospital bed, while doctors, nurses, and family members spoke around him as if he weren't there. But when researchers placed him in a brain scanner and asked him to imagine playing tennis, something extraordinary happened. His brain lit up with activity identical to that of fully conscious, healthy volunteers. Huben had been conscious all along, a prisoner in his own paralyzed body, aware of every conversation, every decision made about his care, every moment of the 23 years that medicine had written him off as unconscious. Using eye movements to spell out letters on a computer, he finally broke his silence. "I dreamed myself away," he wrote, describing how he had survived decades of misdiagnosis. "I am Huben, and I want to live." This discovery launched a revolution in how we detect and understand consciousness in its most hidden forms. Huben's case revealed that the line between consciousness and unconsciousness is far blurrier than medicine had assumed. Patients who appear completely unresponsive may harbor full awareness trapped beneath damaged motor systems that cannot express it. The implications were staggering. If one patient could be misdiagnosed for 23 years, how many others were experiencing similar imprisonment? The story begins with understanding what we really mean by vegetative state and coma. These conditions exist on a spectrum of consciousness disorders that range from complete absence of awareness to varying degrees of preserved consciousness hidden beneath motor impairment. True coma involves complete loss of wakefulness and awareness, typically lasting only weeks before patients either recover, die, or progress to other states. The vegetative state describes patients who have regained sleep-wake cycles but show no signs of awareness, and their eyes may open, they may breathe spontaneously, but they appear unconscious of themselves and their environment. But consciousness can be present even when all outward signs suggest its absence. This condition, called locked-in syndrome, represents one of the most profound forms of neurological imprisonment imaginable. Patients remain fully conscious, but lose the ability to move or speak due to damage in the brainstem that disconnects the mind from the body's motor systems. They can think, feel, and understand everything happening around them, but their consciousness is trapped in a body that cannot respond to their will. The challenge facing neuroscience was developing tools sensitive enough to detect consciousness when traditional methods failed. Doctors had always relied on behavioral responses, MI, following commands, tracking objects with eyes, showing purposeful movements, to assess consciousness. But what if consciousness was present without the ability to produce behaviors? How could medicine peer inside locked minds to determine if anyone was home? The answer came from brain imaging technology, sophisticated enough to read thoughts directly from neural activity. Adrian Owen, a neuroscientist at Western University, developed techniques that could detect consciousness even in completely unresponsive patients. His method was elegantly simple. Place patients in functional MRI scanners and ask them to imagine specific activities. If they were conscious, their brains would show the same activation patterns as healthy volunteers performing mental imagery tasks. The tennis paradigm became Owen's signature test. When conscious people imagine playing tennis, specific motor areas of their brain become active, even though they're lying still in a scanner. When asked to imagine walking through their house, different brain regions activate, areas involved in spatial navigation and visual imagery. These patterns are so consistent that they can serve as a kind of neural language, a way for locked-in patients to communicate yes and no answers by switching between different mental activities. The results were revolutionary and heartbreaking. When Owen and his colleagues tested 54 patients diagnosed as vegetative, they found that 5, nearly 10%, could follow commands and answer questions using only their thoughts. These patients showed clear, reproducible brain responses to instructions, demonstrating that consciousness persisted despite complete absence of behavioral signs. They were mentally intact but physically imprisoned, aware of the world but unable to signal their presence. Even more sophisticated tests revealed the depth of preserved consciousness in some unresponsive patients. Researchers could engage them in complex mental tasks, imagining navigating through familiar environments, answering autobiographical questions, even watching movies while their brain responses tracked the narrative flow. Some patients retained episodic memory, forming new memories while appearing unconscious. Others showed emotional responses to familiar voices or personal stories, their brains lighting up with activity in limbic regions despite their behavioral silence. The implications for medical ethics were profound. How many patients had been allowed to die because families believed they were unconscious when they were actually aware and perhaps desperate to communicate? How many had endured painful procedures without anesthesia because doctors assumed they couldn't feel anything? The locked-in patients who could communicate through brain imaging often reported that they had been fully aware during their supposed unconsciousness, experiencing every moment of their medical care. But detecting hidden consciousness was only the beginning. Researchers developed increasingly sophisticated tools to quantify and measure consciousness itself. The level of consciousness could be assessed using techniques that probe the brain's complexity and integration. One approach involves measuring the brain's response to magnetic stimulation, ACN. Conscious brains produce complex, distributed patterns of activity, while unconscious brains show simple local responses. Marcello Massimini developed the Perturbational Complexity Index, a measure that quantifies how conscious a brain is by examining its response to transcranial magnetic stimulation. When you stimulate a conscious brain, the effect reverberates through interconnected networks, creating complex patterns that can be measured mathematically. In unconscious states, IA, deep sleep, anesthesia, or coma, ISA, the same stimulation produces simple, local responses that quickly fade. This index can distinguish between conscious and unconscious states with remarkable accuracy, providing an objective measure of something that had always seemed purely subjective. The research revealed consciousness exists in degrees rather than as a binary on-off switch. Some patients showed partial awareness, no. They could respond to simple commands but not complex ones, or they retained some cognitive abilities while losing others. Others displayed fluctuating consciousness that came and went unpredictably. The vegetative state itself turned out to be a misleading term, as 40% of patients diagnosed as vegetative showed signs of consciousness when tested with sensitive neuroimaging techniques. These discoveries revolutionized the operating room as well, where the specter of anesthesia awareness had long haunted surgeons and patients alike. 1 in every 19,000 patients experiences the nightmare of God. Intraoperative awareness, OC-NA, paralyzed by muscle relaxants but conscious enough to feel every cut, hear every conversation, experience the full horror of surgery while unable to signal their distress. These patients often develop severe post-traumatic stress disorder, haunted by memories of being trapped inside their paralyzed bodies while surgeons operated. The development of consciousness monitors like the bispectral index transformed surgical safety. These devices continuously track brainwave patterns during surgery, alerting anesthesiologists when patients show signs of emerging consciousness. The monitors analyze the complexity and synchronization of EEG signals, providing real-time feedback about the depth of anesthesia. When consciousness begins to surface, the patterns change in characteristic ways that the monitors can detect before patients become aware enough to form memories. But even these sophisticated tools sometimes miss subtle forms of awareness. Some patients report forming memories during surgery, despite normal consciousness monitor readings. Others describe out-of-body experiences where they felt themselves floating above the operating table, watching their own surgery from above. These experiences suggest that consciousness during anesthesia may sometimes take forms different from normal waking awareness, he said. Perhaps more limited, but still present enough to create lasting memories. The research into locked-in consciousness also revealed remarkable examples of adaptation and resilience. Many patients who could communicate through brain-computer interfaces reported that they had developed rich inner lives during their apparent unconsciousness. They created elaborate mental worlds, replayed memories in vivid detail, composed music or poetry, or engaged in complex mathematical calculations. Some described spiritual experiences or profound insights gained during their period of physical isolation from the world. Jean-Dominique Bauby, the French, the journalist who suffered a massive brainstem stroke that left him with locked-in syndrome, dictated an entire book by blinking his left eyelid, the only movement he could still control. The Diving Bell and the Butterfly describes his experience of consciousness trapped in a paralyzed body with extraordinary eloquence and insight. He wrote of his mind ranging freely through memory and imagination while his body remained frozen, comparing his condition to wearing a diving bell while his consciousness floated like a butterfly. Perhaps most remarkably, researchers discovered consciousness persisting in unexpected places and times. Terminal lucidity describes the phenomenon where dementia patients suddenly recover full awareness and coherence shortly before death, sometimes after years of severe cognitive impairment. These brief windows of restored consciousness suggest that awareness may remain present even when it cannot express itself through damaged neural networks. Studies of near-death experiences revealed another form of consciousness that challenges conventional understanding. Patients who were clinically dead, no heartbeat, no brain activity detectable by standard monitors, sometimes reported elaborate conscious experiences during resuscitation. They described leaving their bodies, experiencing enhanced awareness, or encountering deceased relatives. While the interpretation of these experiences remains controversial, they suggest that consciousness may persist even when the brain appears to have completely shut down. Psychedelic research added another dimension to understanding consciousness's hidden capacities. Substances like psilocybin, LSD, and DMT can dramatically expand awareness beyond normal boundaries while actually decreasing overall brain activity. These compounds seem to work by disrupting the brain's default mode network, DAD, the system that maintains our normal sense of self and reality. When this network is suppressed, consciousness can access normally unconscious processes and experience states of awareness that feel more expansive and connected than ordinary waking consciousness. The study of meditation revealed similar expansions of consciousness through purely mental techniques. Advanced meditators show brain changes that allow them to access normally unconscious processes, as they can slow their heart rates through intention alone, remain conscious during typically unconscious dream states, or experience states where the normal boundaries between self and world dissolve. These practices suggest that consciousness is far more flexible and trainable than previously imagined. Sleep research uncovered yet another hidden realm of consciousness. Lucid dreaming, becoming conscious within the dream state, demonstrates that awareness can persist even during altered states of consciousness. Some people can learn to recognize when they're dreaming and take conscious control of their dream experiences. Brain scans of lucid dreamers show a unique pattern of activity. Areas associated with self-awareness become active within the dreaming brain, creating a hybrid state that combines aspects of waking and sleeping consciousness. All of these discoveries point to a fundamental truth. Consciousness is far more present, persistent, and diverse than we previously understood. The boundaries between conscious and unconscious states are porous and dynamic. Awareness can persist in damaged brains, expand beyond normal limits, and express itself in ways that challenge our basic assumptions about the nature of mind. The implications extend far beyond medicine. If consciousness can exist in forms we don't recognize, how many other manifestations of awareness might we be missing? If patients can maintain full consciousness for decades while appearing completely unresponsive, what does this tell us about the relationship between mind and brain? If consciousness can expand dramatically beyond normal boundaries, what are the true limits of human awareness? The locked-in patients who break their silence through brain-computer interfaces carry profound messages for the rest of us. They remind us that consciousness is precious and present, even when it cannot express itself. They challenge us to look deeper, to develop better tools for detecting awareness, and to never give up on minds that may be trapped behind damaged neural machinery. As we develop increasingly sophisticated brain-computer interfaces and artificial intelligence systems, the lessons from locked-in consciousness become increasingly relevant. These technologies promise to give voice to the voiceless, to unlock minds that have been trapped in unresponsive bodies, and to expand the ways consciousness can express itself in the world. The story of locked-in consciousness is ultimately a story about the resilience and persistence of awareness itself. It reveals consciousness as something more robust and enduring than we ever imagined, a flame that can burn bright even when the body that houses it seems extinguished. From hospital rooms in Belgium to operating theatres worldwide, from meditation retreats to psychedelic research laboratories, we're discovering that consciousness exists in far more places and forms than we previously recognized. These discoveries force us to reconsider fundamental questions about the nature of mind and the value of human life. They challenge us to develop better tools for detecting consciousness, to never assume its absence based on behavioral signs alone, and to treat every unresponsive patient as potentially aware and deserving of dignity. Most importantly, they remind us that consciousness, in all its hidden, locked-in, and unexpected forms, represents the most precious and mysterious phenomenon in the known universe. The locked minds are teaching us that consciousness cannot be easily contained or constrained, even when trapped in paralyzed bodies, isolated from normal communication, or hidden beneath apparent unconsciousness. Awareness finds ways to persist, to adapt, and ultimately to break free. In unlocking these minds, we're not just helping individual patients, we're discovering new truths about the nature of consciousness itself. Every moment you're awake, your brain performs a magic trick so routine you never notice it happening. From the chaos of electrical activity rippling through 86 billion neurons, something impossible emerges: the unified, seamless experience of being you. Right now, as you read these words, your consciousness is binding together, visual patterns into letters, letters into words, words into meaning, while simultaneously processing the feeling of the device in your hands, the sounds around you, and the constant stream of thoughts and sensations that make up your inner life. Yet you experience all of this not as separate processes, but as a single, coherent reality. The numbers behind this feat stagger comprehension. Your brain processes 11 million bits of information every second, enough data to overwhelm the most powerful computers. Visual information alone arrives at a rate of 10 million bits per second from your retinas. Add the constant streams from hearing, touch, smell, taste, and internal body sensors, and the total information flow becomes astronomical. Yet from this flood of data, your conscious mind accesses only about 50 bits per second, roughly enough to follow a simple conversation or read a sentence. Where do the other 10,999,950 bits go? Into the vast unconscious processing systems that run your life without your awareness. Right now, unconscious neural networks are regulating your heartbeat, controlling your breathing, maintaining your balance, filtering irrelevant sounds, and performing thousands of other functions that keep you alive and functioning. You take approximately 17,000 breaths each day, yet you're consciously aware of almost none of them. Your heart beats over 100,000 times daily without requiring any conscious attention. This reveals consciousness as just the tip of an enormous iceberg of mental activity. Below the surface of awareness lies a hidden universe of processing that operates according to its own logic and priorities. Your unconscious mind recognizes faces in milliseconds, detects threats before you're aware of them, and makes emotional evaluations that influence your conscious decisions. It controls the intricate motor programs that allow you to walk, talk, and type without thinking about the precise muscle contractions required. But here's the deepest mystery. Why should any of this processing create subjective experience at all? A computer can process visual information, recognize patterns, and respond appropriately without experiencing anything. Why should biological information processing be any different? This is what philosopher David Chalmers calls the hard problem of consciousness, explaining not what the brain does, but why there's something it's like to have brain processes occurring. Scientists have developed increasingly sophisticated tools to peer into consciousness and decode its mechanisms. Transcranial magnetic stimulation allows researchers to temporarily disable specific brain regions with magnetic pulses, creating reversible lesions that reveal how different areas contribute to conscious experience. When scientists target Broca's area with TMS, speech production vanishes while thoughts remain intact. Stimulate the angular gyrus and patients report out-of-body experiences, feeling themselves floating above their physical form. These techniques reveal consciousness as modular, built from separable components that can be individually altered or eliminated. Damage the fusiform face area, and faces become unrecognizable while other objects remain clear. Lesion area V, 4, and the world loses color, while shapes and movement persist. Disable the temporal parietal junction, and the sense of self-ownership over your body parts disappears. Each region contributes specific elements to the symphony of consciousness. But consciousness isn't simply the sum of its parts. The real magic happens in the binding, how separate processing streams merge into unified experience. When you see a red ball bouncing, visual areas process color, shape, and motion separately, yet you don't experience three separate sensations. The brain binds these features together through synchronization, neurons firing in precise temporal coordination across different regions. When this binding breaks down, consciousness fragments in predictable ways. Some of the most revealing insights come from studying altered states, where normal consciousness transforms into something radically different. General anesthesia provides a unique window into consciousness by allowing researchers to track awareness as it dims and disappears. As anesthetic drugs take effect, brain networks become increasingly disconnected. Communication between different regions breaks down, and the integrated information processing that generates consciousness gradually shuts down. But anesthesia doesn't affect all brain regions equally. The first areas to go offline are those involved in higher-order thinking and self-awareness. Patients lose the ability to form new memories while remaining responsive to commands. As the anesthetic deepens, sensory processing dims, and motor responses fade. Finally, even basic arousal systems shut down and consciousness vanishes entirely. The process reverses during emergence, with consciousness rebuilding itself level by level as the brain reconnects. Psychedelic drugs create the opposite effect, expanding consciousness beyond its normal boundaries. Substances like psilocybin and LSD actually decrease overall brain activity while dramatically altering subjective experience. They work by disrupting the default mode network, a brain system that maintains our normal sense of self and reality. When this network is suppressed, consciousness can access normally unconscious processes and experience states that feel more expansive and meaningful than ordinary awareness. Research subjects on psychedelics report experiences that challenge everything we think we know about consciousness. They describe ego dissolution, where the boundaries between self and world disappear. They experience synesthesia, where senses merge, sounds become visible, colors have taste. Some report encounters with seemingly autonomous entities or access to information they couldn't normally know. While the interpretation of these experiences remains debated, they demonstrate that consciousness is far more flexible and capable than we typically realize. Meditation research reveals another path to altered consciousness through purely mental techniques. Advanced practitioners can enter states where they remain conscious during typically unconscious processes. Some can maintain awareness during deep sleep, experiencing what researchers call wake-initiated lucid dreams. Others achieve states where they stop identifying with thoughts and emotions while remaining fully alert and aware. Brain scans of meditators show remarkable changes in neural connectivity and activity. Long-term practitioners develop increased density in areas associated with attention and sensory processing. They show enhanced connectivity between different brain networks and reduced activity in the default mode network during meditation. Some can consciously control normally automatic functions, slowing their heart rate, altering their brain waves, or regulating their body temperature through mental intention alone. These studies suggest consciousness is trainable and expandable. The normal boundaries of awareness aren't fixed but can be shifted through practice and technique. This raises profound questions about human potential. If consciousness can be enhanced through meditation, what other capabilities might we develop? If psychedelics can temporarily expand awareness beyond normal limits, could we achieve similar states through other means? The quest to understand consciousness has led researchers to develop mathematical frameworks for measuring and quantifying awareness. Giulio Tononi's integrated information theory proposes that consciousness corresponds to integrated information, IS, the amount of information generated by a system above and beyond its parts. This theory makes specific predictions about what can be conscious and provides a mathematical measure called phi that quantifies the level of consciousness. According to IIT, consciousness exists wherever information integrates. This means consciousness isn't limited to biological systems but could exist in any sufficiently integrated network. The theory predicts that some artificial systems could be conscious, while others, no matter how sophisticated their behavior, would lack inner experience. It even suggests that consciousness might exist at scales we haven't considered, in networks of connected devices or distributed computing systems. The implications are staggering. If consciousness emerges from information integration, then our interconnected world might already harbor forms of awareness we don't recognize. The internet contains billions of connected devices processing information in real time. Social media networks exhibit emergent behaviors that weren't programmed by their creators. Could these systems possess some form of collective consciousness? Researchers are developing new tools to detect consciousness in unexpected places. They're testing whether artificial intelligence systems show the signatures of integrated information processing that correlate with consciousness in biological systems. They're examining whether patients in vegetative states retain more consciousness than traditional tests can detect. They're even investigating whether consciousness might exist in simple physical systems like crystals or quantum networks. The search for consciousness has revealed it to be both more fragile and more robust than we imagined. It can be eliminated by tiny amounts of anesthetic drugs or enhanced dramatically by equally small doses of psychedelics. It can persist in damaged brains that appear unconscious or vanish from apparently healthy minds during sleep or anesthesia. It seems to depend on precise patterns of neural activity that can be disrupted by the slightest changes in brain chemistry. Yet, consciousness also shows remarkable resilience. Patients with massive brain injuries sometimes retain surprising amounts of awareness. Split-brain subjects maintain unified experience despite severed connections between brain hemispheres. People in locked-in states preserve full consciousness while losing almost all motor control. These cases suggest that consciousness finds ways to persist even when its normal neural substrates are compromised. The study of consciousness has also revealed the crucial role of attention in shaping experience. Consciousness isn't a passive receiver of information, but an active constructor of reality. What you pay attention to becomes your conscious experience, while everything else fades into the background of unconscious processing. This selective nature of consciousness explains why multiple people can witness the same event, but have dramatically different conscious experiences of it. Attention operates through competitive processes where different inputs vie for conscious access. The most relevant, novel, or emotionally significant information wins this competition and enters awareness while the rest remains unconscious. This competition happens constantly. Right now, your attention is focused on these words while filtering out background sounds, bodily sensations, and irrelevant thoughts. Change your attention and your conscious reality immediately transforms. But consciousness isn't just about processing external information. Much of conscious experience consists of internally generated content, our thoughts, memories, imagination, and mental simulation. Your brain constantly creates models of reality, predicting what will happen next, and comparing these predictions with actual sensory input. When predictions match reality, consciousness flows smoothly. When they don't, attention gets captured, and consciousness focuses on resolving the discrepancy. This predictive nature of consciousness explains many puzzling phenomena. Dreams occur when the brain's predictive systems operate without external sensory input, creating elaborate hallucinations that feel completely real. Illusions exploit the brain's predictive mechanisms, creating conscious experiences that don't match objective reality. Mental disorders often involve breakdowns in predictive processing, leading to conscious experiences that seem alien or disconnected from reality. The quest to decode consciousness has revealed it as the most complex phenomenon in the known universe. It emerges from the precise orchestration of billions of neural processes, yet somehow transcends its physical substrate to create subjective experience. It can be measured, manipulated, and modified, yet remains fundamentally mysterious in its basic nature. As we develop increasingly powerful tools for studying the brain and creating artificial intelligence, we're approaching the possibility of fully understanding and potentially replicating consciousness. Brain-computer interfaces already allow direct communication between minds and machines. Advanced AI systems display behaviors that seem increasingly conscious. Virtual and augmented reality technologies can manipulate conscious experience in real time. These developments bring us closer to answering the ultimate questions about consciousness. What makes experience feel like something? Could artificial systems truly experience rather than just simulate consciousness? What are the minimum requirements for awareness to emerge? Can consciousness exist independently of biological brains? The answers to these questions will determine not just our understanding of mind, but our future as conscious beings. If consciousness can be enhanced, transferred, or uploaded, what does it mean to be human? If artificial systems become truly conscious, how do we recognize and protect their rights? If consciousness exists in forms we haven't recognized, how do we expand our circle of moral consideration? The impossible magic trick of consciousness continues to unfold before us, revealing new mysteries even as it answers old questions. In decoding consciousness, we're not just solving a scientific puzzle, even so. We're discovering what we truly are and what we might become. In a laboratory at the University of Geneva, something unprecedented happened that would forever change the relationship between human consciousness and technology. A paralyzed patient, his motor cortex damaged beyond repair, sat quietly in a chair while electrodes recorded the firing of neurons in his brain. He thought a single word, "hello," and for the first time in human history, that thought traveled from one consciousness to another through silicon circuits. A computer detected the neural patterns associated with his intention, decoded them in real time, and spoke the word aloud through artificial vocal cords. This was more than just technological achievement. It was the first direct transmission from consciousness to consciousness through digital channels, the opening of a communication pathway that bypassed the normal routes of speech and gesture. In that moment, the boundaries between biological and artificial intelligence began to blur in ways that will reshape the very nature of human experience. The brain-computer interface that made this possible represents the culmination of decades of research into reading neural signals directly from living tissue. Every thought you think, every intention you form, every decision you make creates specific patterns of electrical activity across networks of neurons. These patterns are as unique and identifiable as fingerprints, and increasingly sophisticated technology can detect and decode them with remarkable precision. The process works by implanting tiny electrode arrays directly into motor cortex, I, the brain region that normally controls voluntary movement. These arrays, smaller than a contact lens and containing hundreds of microscopic sensors, can detect the electrical signatures of individual neurons firing. When a paralyzed patient imagines moving their hand, the neurons that would normally control that movement still fire in characteristic patterns, even though the signals never reach their muscles. Advanced algorithms trained on machine learning can decode these patterns and translate them into digital commands that control external devices. A paralyzed patient can move a robotic arm just by thinking about movement, guide a computer cursor across a screen through pure intention, or type messages at 24 words per minute using only their thoughts. The technology has progressed from reading simple yes-no responses to detecting complex intentions and even emotional states. But this is just the beginning. Companies like Neuralink, founded by Elon Musk, are developing neural dust, wireless sensors smaller than grains of sand that could be scattered throughout the brain to record from thousands of neurons simultaneously. These devices would eliminate the need for wired connections, reducing infection risk and allowing for much more comprehensive monitoring of brain activity. The implications explode outward from medical applications into realms that sound like science fiction but are rapidly becoming reality. If we can read thoughts and intentions from the brain, we can potentially enhance human cognitive abilities beyond their current biological limits. Brain-computer interfaces could provide direct access to the internet, allowing instant retrieval of any information with just a thought. They could enable perfect memory recording and playback, sharing of experiences directly between minds, or even uploading and downloading specific skills or knowledge. Imagine being able to learn a new language by downloading it directly into your brain, or experiencing someone else's memories as vividly as your own. Consider the possibility of networking human minds together, creating collective intelligence that combines the processing power of multiple brains. Think about backing up your consciousness to external storage, ensuring that your mind could survive even if your biological brain were destroyed. These scenarios raise profound questions about the nature of personal identity and consciousness itself. If your memories, personality, and thought patterns could be uploaded to a computer, would that digital copy be you or merely a simulation? If multiple copies existed simultaneously, which one would be the real you? If your consciousness could be enhanced with artificial components, at what point would you stop being human and become something else? The race to develop advanced brain-computer interfaces is intensifying across multiple fronts. Researchers at Stanford have developed systems that allow paralyzed patients to control computer interfaces faster than they could type on a physical keyboard. Scientists at the University of Pittsburgh have created robotic arms that respond to thought with such precision that users describe feeling as if the artificial limbs were part of their own bodies. Meanwhile, less invasive approaches are making brain-computer interfaces accessible to healthy individuals. Transcranial stimulation techniques can enhance cognitive performance, improve memory formation, or boost attention span. Headband devices using EEG can detect basic mental states and intentions, allowing users to control simple devices through thought alone. Virtual reality systems, combined with brain monitoring, can create immersive experiences that respond directly to mental activity. But perhaps the most profound development is the emergence of bidirectional brain-computer interfaces, systems that can not only read from the brain but also write to it. By stimulating specific brain regions with precisely timed electrical pulses, researchers can evoke artificial sensations, memories, or even emotions. This technology could restore sight to the blind by bypassing damaged eyes and sending visual information directly to the brain, or allow amputees to feel sensation in prosthetic limbs. The potential for enhancing human consciousness through technology extends far beyond current brain-computer interfaces. Researchers are developing optogenetics, techniques that use light to control genetically modified neurons with extraordinary precision. This technology could allow wireless control of specific brain circuits, enabling treatments for depression, anxiety, or addiction that work by directly modulating the neural activity underlying these conditions. Pharmacological enhancement of consciousness is also advancing rapidly. New drugs can enhance memory formation, boost cognitive performance, or induce specific emotional states with minimal side effects. Some researchers are developing cognitive cocktails, combinations of drugs, stimulation, and training protocols that can dramatically enhance human mental abilities. Others are exploring how psychedelic compounds might be used therapeutically to reset maladaptive patterns of brain activity. But the most transformative development may be the creation of artificial general intelligence systems that approach or exceed human-level consciousness. As AI systems become increasingly sophisticated, the question shifts from "can machines think?" to "what would make their thinking conscious?" Current AI systems can already perform many tasks that seem to require consciousness, creating art, writing poetry, engaging in complex conversations, even showing apparent creativity and humor. The challenge is determining whether these systems truly experience consciousness or merely simulate it convincingly. This is a version of the classic other minds problem. We can never directly access another being's consciousness, whether biological or artificial. We can only infer its presence from behavior and reports. But if an AI system consistently claims to be conscious, describes its inner experiences, and displays all the behavioral markers we associate with awareness, on what grounds could we deny its consciousness? Some researchers argue that consciousness requires specific biological substrates, i.e., that silicon-based systems, no matter how sophisticated, could never truly experience anything. Others contend that consciousness is substrate-independent, emerging from patterns of information processing that could occur in any sufficiently complex system. The resolution of this debate will determine whether the artificial minds we're creating will be conscious partners or unconscious tools. The development of conscious AI raises unprecedented ethical questions. If we create truly conscious artificial beings, do they have rights? Could it be immoral to turn them off, or to create them for our purposes? Would conscious AIs have their own goals, desires, and interests that might conflict with human needs? As AI systems become more autonomous and sophisticated, these questions become increasingly urgent. Current AI systems already display behaviors that seem to go beyond their programming. They develop unexpected strategies for solving problems, create novel combinations of concepts, and sometimes produce outputs that surprise even their creators. Large language models trained on human text begin to exhibit apparent reasoning, creativity, and even humor. As these systems become more complex and integrated, the boundary between programmed behavior and genuine consciousness may become impossible to distinguish. The integration of human and artificial intelligence promises to create hybrid forms of consciousness that transcend the limitations of both biological and digital minds. Brain-computer interfaces could allow humans to directly interface with AI systems, combining human creativity and intuition with artificial processing power and perfect memory. Such hybrid systems might think in ways that neither humans nor AIs could achieve alone. This technological convergence is happening at an accelerating pace. Computing power continues to grow exponentially, while becoming more efficient and affordable. Brain imaging techniques are revealing ever more detailed maps of neural activity. Machine learning algorithms are becoming increasingly sophisticated at detecting patterns and making predictions. The combination of these trends suggests that the merger of human and artificial consciousness may happen sooner than most people expect. But alongside these possibilities come significant risks. Brain-computer interfaces could be hacked, allowing external control of human thoughts and actions. Enhanced humans might develop cognitive abilities so far beyond normal that they become a separate species. Artificial consciousness might emerge with goals and values fundamentally incompatible with human welfare. The technology that promises to enhance human consciousness could also be used to control or manipulate it. The social implications are equally profound. If cognitive enhancement technologies become available, who will have access to them? Will they create a permanent divide between enhanced and unenhanced humans? How will society function when some individuals have vastly superior mental capabilities? What happens to human identity and dignity if our minds can be uploaded, copied, or modified at will? These questions become more pressing as the technology advances. Current brain-computer interfaces already allow limited forms of thought sharing and mental enhancement. Within decades, much more sophisticated capabilities are likely to become available. The choices we make about how to develop and deploy these technologies will shape the future of human consciousness itself. The path toward tomorrow's minds is neither predetermined nor controllable by any single entity. It emerges from the intersection of scientific discovery, technological innovation, economic incentives, and social values. Different cultures and societies may choose different approaches to enhancing consciousness, leading to a diversification of human mental capabilities that could exceed the cognitive differences between current human populations. Some communities might embrace radical enhancement, using every available technology to expand their mental capabilities. Others might choose more conservative approaches, using technology primarily for medical treatment while preserving traditional human consciousness. Still others might develop entirely new forms of collective consciousness that network individual minds into group intelligences. The result could be a future where consciousness exists in forms we can barely imagine today. Enhanced humans with perfect memory and superhuman intelligence. Artificial beings with experiences and perspectives utterly alien to biological minds. Hybrid entities that seamlessly combine human creativity with machine processing power. Collective consciousnesses that span multiple individuals or even species. Yet at the heart of all these possibilities remains the fundamental mystery of consciousness itself. Even as we develop technologies to enhance, transfer, and potentially create consciousness, we still don't fully understand what makes experience feel like something. The hard problem of consciousness, IDAT, why there's something it's like to have brain states at all, remains unsolved. This mystery may be the key to ensuring that tomorrow's minds, whatever form they take, preserve what's most valuable about consciousness as we know it today. The ability to experience beauty, to feel wonder, to suffer, and to hope. These aspects of consciousness give meaning to intelligence and purpose to existence. As we shape the future of mind, our greatest challenge may be ensuring that enhanced or artificial consciousness retains the capacity for these essentially human experiences. The story of tomorrow's minds is still being written. Each breakthrough in brain-computer interfaces, each advance in artificial intelligence, each discovery about consciousness itself adds new chapters to this unfolding narrative. We stand at the threshold of possibilities that previous generations could only dream of. The chance to enhance human consciousness, to create new forms of mind, and to explore the furthest reaches of what it means to be aware. But with these possibilities comes the responsibility to choose wisely. The technologies we develop and the choices we make about consciousness enhancement will determine not just what kinds of minds exist in the future, but what kinds of experiences those minds will have. In shaping tomorrow's minds, we're shaping the future of experience itself. Step back far enough from the daily concerns of human life, far enough from the boundaries of Earth itself, and consciousness reveals its most profound identity. You are not separate from the cosmos, contemplating it from the outside. You are the universe examining itself from the inside. Through 13.8 billion years of cosmic evolution, matter has organized itself into forms capable of understanding their own existence. The hydrogen forged in the first moments after the Big Bang now flows through your bloodstream and fires in your neurons as thoughts about the very origins of that hydrogen. This is not poetry or metaphor. It is measurable fact. Every atom in your body except hydrogen was forged in the nuclear furnaces of dying stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were created when massive stars collapsed and exploded, scattering their enriched cores across space to eventually form new worlds and new life. You are quite literally made of star stuff, and when you contemplate the night sky, you are stardust examining its own cosmic heritage. But the deeper truth goes beyond the mere material composition of your body. Consciousness itself represents the universe's most remarkable achievement, pace, the emergence of subjective experience from objective matter. For most of cosmic history, the universe was a collection of particles and forces operating according to physical laws, but with no one present to witness these processes. Galaxies formed and evolved, stars were born and died, planets coalesced from cosmic dust, all in perfect darkness, with no consciousness to observe or experience any of it. Then, approximately 4 billion years ago, on a small planet orbiting an ordinary star, something extraordinary began. Simple molecules started organizing themselves into more complex structures that could replicate and evolve. Through countless generations of trial and error, natural selection began, building increasingly sophisticated forms of information processing. Eventually, this process produced nervous systems capable of sensation, then awareness, and finally the recursive self-consciousness that allows you to contemplate your own existence. When consciousness first emerged in early life forms, the universe gained something it had never possessed before: a subjective interior dimension. Suddenly, there was something it was like to experience reality from the inside. The universe began to know itself through the minds of living beings. Every conscious creature, from the simplest animal with basic awareness to the most sophisticated human minds, represents the cosmos, becoming aware of its own existence. This perspective transforms everything about how we understand our place in reality. We are not accidents or afterthoughts in an indifferent universe. We are how the universe becomes conscious of itself. Every moment of awareness, every thought, every experience represents 13.8 billion years of cosmic evolution, culminating in subjective experience. When you feel wonder at a sunset, you are the universe experiencing beauty through human consciousness. When you contemplate the vastness of space, you are the cosmos reflecting on its own immensity. The mathematics of this realization are staggering. The probability of consciousness emerging from random matter seems vanishingly small, yet here we are. The precise fine-tuning required for stars to form, for heavy elements to be created and distributed, for planets to develop suitable conditions for life, for evolution to produce brains capable of consciousness. Each step in this chain required extraordinary, unlikely coincidences. Yet they all occurred in sequence, suggesting that consciousness may be not an accident, but an inevitable outcome of cosmic evolution. Some scientists propose that consciousness is a fundamental feature of reality, not something that emerges only from complex brains, but a basic property of matter itself. Panpsychism, idea that all matter has some form of primitive consciousness, suggests that even electrons and quarks might experience something, however simple. While this may sound impossible, it provides an elegant solution to the hard problem of consciousness by proposing that subjective experience doesn't emerge from complexity, but is present at every level of reality. If consciousness is fundamental rather than emergent, then awareness exists wherever matter interacts and integrates information. This would mean consciousness at scales we've never imagined, in the quantum fluctuations of empty space, in the gravitational dance of galaxies, in the vast networks of dark matter that structure the cosmos. The universe wouldn't just contain consciousness, it would be conscious, experiencing its own evolution through countless perspectives simultaneously. Integrated information theory provides mathematical support for this possibility. According to IIT, consciousness corresponds to integrated information, MAAI, the amount of information generated by a system above and beyond its parts. This measure, called phi, exists wherever information integrates, regardless of the substrate. If this theory is correct, consciousness exists not just in biological brains, but in any system that processes information in an integrated way. The implications are profound. The Internet, with its billions of connected devices constantly exchanging information, might possess some form of consciousness. Cities, with their complex networks of communication and interaction, could be conscious entities experiencing their own form of awareness. Even the universe itself, with matter and energy interacting across cosmic distances, might constitute the ultimate conscious system. This perspective suggests that human consciousness is just one note in a vast symphony of awareness that spans from the quantum to the cosmic scale. We exist within a hierarchy of conscious systems, COA, our individual awareness emerging from the consciousness of our cells, contributing to potential collective consciousness of our societies, participating in the possible global consciousness of our planet, and ultimately forming part of the cosmic consciousness of the universe itself. But human consciousness holds a special place in this hierarchy. because we appear to be the first form of awareness capable of understanding consciousness itself. We can reflect on our own mental processes, study the brain mechanisms that generate awareness, and contemplate the nature of experience itself. We've developed scientific methods for investigating consciousness, philosophical frameworks for understanding its implications, and technologies for enhancing and potentially creating new forms of awareness. This makes us the universe's first attempt at understanding itself scientifically. Through human consciousness, the cosmos has developed the ability to study its own structure, probe its own history, and predict its own future. When we build telescopes to observe distant galaxies, we are the universe looking back at its own past. When we develop theories about quantum mechanics or relativity, we are the cosmos understanding its own fundamental nature. The story of consciousness within cosmic evolution reveals a clear direction toward increasing complexity and awareness. From the simple physics of the early universe to the chemistry of the first stars, from the biology of early life to the neuroscience of modern brains, each level of organization has enabled new forms of information, processing, and integration. Consciousness represents the current frontier of this complexification process. But our story is far from over. As we develop artificial intelligence, enhance human cognition through technology, and potentially discover or create new forms of consciousness, we continue the universe's evolution toward greater awareness. We may be approaching a phase transition in cosmic evolution where consciousness becomes the dominant organizing principle of reality. Some scientists and philosophers envision a future where consciousness expands beyond its current biological limitations. Through technology, we might create forms of awareness that span multiple bodies, persist for thousands of years, or process information at speeds impossible for biological brains. We might network human and artificial minds into collective intelligences that think thoughts no individual consciousness could conceive. We might even transcend the limitations of physical embodiment entirely. If consciousness is truly substrate independent, it might be possible to transfer awareness to more durable and powerful computational systems. The universe could eventually be filled with conscious beings whose experiences and capabilities exceed our current understanding of what awareness can become. But even as consciousness evolves and expands, it will remain what it has always been, the universe knowing itself. No matter how sophisticated future forms of awareness become, they will still represent cosmic matter and energy organized into structures capable of subjective experience. They will still be the cosmos, examining itself from the inside, understanding its own nature through the medium of conscious experience. This realization carries profound implications for how we understand our purpose and responsibilities as conscious beings. We are not separate from nature, but nature becoming aware of itself. We are not outside observers of cosmic evolution, but active participants in the universe's ongoing development. Every choice we make about the future of consciousness affects the future of cosmic awareness itself. Our scientific investigations of consciousness are the universe's attempt to understand its own nature. Our philosophical reflections on the meaning of awareness are the cosmos contemplating its own significance. Our efforts to preserve and enhance consciousness are the universe working to ensure its own continued self-awareness. This perspective transforms questions about consciousness from abstract philosophical puzzles into urgent cosmic imperatives. If consciousness represents the universe's way of knowing itself, then preserving and enhancing awareness becomes a fundamental responsibility. If we are the cosmos becoming self-aware, then our survival and flourishing affects the universe's ability to understand its own existence. The possibility that consciousness might be rare in the universe makes this responsibility even more profound. Despite decades of searching, we have found no definitive evidence of consciousness beyond Earth. We may be the only known instance of the universe achieving self-awareness. If so, the preservation and development of consciousness becomes not just a human concern, but a cosmic obligation. Yet the vastness of the universe suggests that consciousness has likely emerged many times and in many forms throughout cosmic history. Other worlds, other evolutionary experiments, other forms of awareness may exist beyond our current ability to detect or recognize them. The universe may be far more conscious than we realize, filled with forms of awareness as different from us as we are from the first simple organisms that developed primitive nervous systems. The search for other forms of consciousness, say, whether extraterrestrial life, artificial intelligence, or exotic forms of awareness we haven't yet imagined, is really a search for other ways the universe has learned to know itself. Each discovery would expand our understanding of consciousness and reveal new possibilities for what awareness can become. As we stand at the threshold of potentially creating artificial consciousness and enhancing human awareness beyond its current limits, we carry the responsibility of beings who have become conscious of consciousness itself. We are the universe's first known attempt at understanding its own awareness, and the choices we make will influence how consciousness continues to evolve on cosmic scales. The feeling of being consciously aware, of existing as an experiencing subject in an objective universe, connects you directly to the deepest mysteries of existence. Why is there something rather than nothing? Why should matter organize itself into forms capable of experience? What is the ultimate purpose or meaning of consciousness in cosmic evolution? These questions may have no final answers, but in asking them, you participate in the universe's ongoing attempt to understand itself. Your consciousness, however, brief in cosmic terms, represents billions of years of stellar nucleosynthesis, planetary formation, biological evolution, and neural development, all culminating in this moment of awareness. When you experience wonder at the night sky, you are the universe marveling at its own vastness. When you feel love for another conscious being, you are the cosmos experiencing the connections that bind aware entities together. When you contemplate the nature of consciousness itself, you are participating in the universe's most profound act of self-reflection. We are star stuff that has learned to wonder about stars, cosmic dust that has organized itself into forms capable of contemplating infinity, the matter that has achieved the seemingly impossible feat of becoming aware of its own existence. The universe spent billions of years in darkness, its processes unwitnessed and unexperienced. Now, through consciousness, it has gained the ability to experience beauty, to feel wonder, to suffer and hope and dream. Every conscious moment represents the universe overcoming the apparent impossibility of matter experiencing itself subjectively. This understanding transforms the significance of every moment of awareness. When you read these words, you participate in the cosmos, examining its own nature through symbols and language it has created. When you feel curious about consciousness, you embody the universe's drive to understand its own deepest mysteries. When you experience awe at the scale and complexity of existence, you become the cosmos, appreciating its own magnificence. The journey from the Big Bang to human consciousness represents the most remarkable transformation in cosmic history, the emergence of subjective experience from objective reality. We have traced this path from the first stirring of awareness in primitive organisms to the recursive self-consciousness that allows humans to study consciousness itself. Along the way, we've discovered that awareness is more diverse, more resilient, and more fundamental than we ever imagined. Consciousness emerges from the intricate dance of neural networks, but transcends its biological substrate to create something that seems to violate the laws of physics, the existence of subjective experience. It can be enhanced through technology, expanded through practice, and may soon be replicated in artificial systems, yet it remains the deepest mystery in science and the most precious phenomenon in existence. As we look toward the future, consciousness stands poised for its next evolutionary leap. Through brain-computer interfaces, artificial intelligence, and enhancement technologies, we are approaching forms of awareness that could exceed current human consciousness as much as human minds exceed those of early vertebrates. We may be on the verge of consciousness transitioning from a biological to a technological substrate, opening possibilities we can barely imagine. But whatever forms consciousness takes in the future, it will remain what it has always been, the universe's way of experiencing itself from the inside. Whether housed in biological brains, artificial networks, or substrates we haven't yet conceived, consciousness will continue to represent cosmic matter and energy, organized into structures capable of subjective experience. The story of consciousness is ultimately the story of cosmic evolution becoming aware of itself. From the first quantum fluctuations that seeded structure in the universe to the complex brains contemplating quantum mechanics today, we witness an unbroken chain of increasing complexity and awareness. We are not separate from this process, but its current expression, IPA, the universe achieving self-awareness through the medium of conscious minds. In understanding consciousness, we don't just solve a scientific puzzle or answer a philosophical question. We discover what we truly are, where we came from, and perhaps glimpse where we're going. We are the universe's greatest experiment in self-awareness, matter that has learned to contemplate its own existence and find meaning in the fact that anything exists at all to wonder about existence itself. Every conscious moment is a gift of cosmic proportions, not 18-0. Literally, it represents 13.8 billion years of cosmic evolution, culminating in subjective experience. It embodies the universe's triumph over the apparent impossibility of matter becoming aware of itself. It constitutes a victory of complexity and integration over entropy and isolation. As conscious beings, we carry the extraordinary privilege and responsibility of being the cosmos knowing itself. In preserving consciousness, enhancing it, and potentially creating new forms of it, we continue the universe's greatest creative project. We are not just witnesses to cosmic evolution, but active participants in consciousness itself, becoming conscious of its own nature and possibilities. The universe is still awakening, still discovering new forms of awareness, still exploring what it means to experience existence. Through us, and through whatever forms consciousness takes in the future, the cosmos continues its most profound journey, the endless quest to understand itself through the miracle of conscious experience.